Right, and let me start the class 1 minute. So the last class I given some assignment, I think. 6 p.m. So how many of you done that book details and yesterday I'm trying to explain PC register area anyway. So meanwhile, hope you understood method area where class loads or classes will be loaded, heap area where objects are created, Java stack area where methods are executed. Where methods are executed. Sure. So these three parts you got some small clarity, you got it. So based on that, some people are trying the assignments also. So anyway, the process is going on. So let me go forward and complete it. Yesterday I had small environment disturbance. I not yet concluded. Okay, let me conclude this. Now PC register area and native method area. PC register area and native method area. So let me complete the two parts and go forward. So program counter registers. Program counter registers will record the status of method executions in Java stack area. PC register, program counter registers will record the status of method executions in Java stack area. In this process, every method will have its own program counter register. Every method will have its own program counter register. I want to know, sir. See there? Yesterday I started like this. When the main method copied onto Java stack area, one separate program counter register is created. Entering the main method. I want to know, sir, how it monitors. See there. Now this line 1 is executed. When the line 1 is executed, it records now. So line 1 execution is going on. It starts with line 2. So line 2 execution is going on. Line 3 execution is going on. It's going to record it. When the line 4 came now, example, from here, execution control will be calling this method. It will record it. So in the line 4, there is one method call. And by the line number 4, the execution control. By the line number 4, the execution control left this method and gone to add method. The execution control will leave this main method, go for add method. Why means you are calling a method, no? It will come here. So whenever the add method came now, it leaves the main method and go for the add method. Why, sir? Anybody can say what is stack now? What is the algorithm stack? Anybody can say what is the algorithm stack? First in, last out, or last in, first out. First in, last out, or last in, first out. So who came last now? Sir, when compared to main method, add came last. So add should go first, no? So the execution control will go to add method. By leaving this main method, control will go to add method. When the control is going to add method, the program counter cannot go. Sorry, it leaves the main method and the control will go to add. When the control came to add method now, here one more program counter register will record it. Here one more program counter register is generated. It is pointing to the add method. It is pointing to the add method. Now this program counter start recording now. Line number 1 executing, line number 2 executing, dot, and so on. When the method execution completed, the method frame destroys. When the method frame destroys, automatically program counter destroys. After this program counter destroyed, the execution control will come down because add method came, I executed, I sent that add method outside. Finish. Now again, I'll come back to the main method. When the execution control came to main method, the execution control should know where I stopped this main method. I should know where I stopped this main method. Then program counter will give the information. By line number 4, you left this main method and gone for add. So now you start with line number 5, that only status. Again, it starts with line number 5 if it is available. Means what? Program counter registers record the status of method execution. Status means which line is running, you left this method by which line, from where you have to start it, and so on. Such informations are maintained by the program counter registers. All of you understood this statement? Say yes or no to me. If not, I'll repeat it. Few people. Now, this design is a old design only, generally. Operating system, computer science department people has operating system. In operating system, we had a PCB. How many of you know PCB? If anybody knows, put the full form of PCB. Computer science engineers. PCB. Other than computer science, don't worry. It is not important now. CSC people, if you can remember, you can write. PCB, CSC people. Process control block. The process control block will record the status of processes executing in operating system. That is the design. From there only, your other brought into your JVM in the form of PCR. In anyway, operating system people are having PCB to control the process. Here we had PCR to control the method. The statuses are recorded part of your PCR, program counter registers. It's a theory. So every method will have its own program counter register. No, every method will have its own program counter register. Like this, if two methods are there, two PCRs will be created. Suppose the add method call one more method. So one more method also will come. Like this, how many methods are copied onto Java stack area? That many program counter registers will be created. So all these program counter registers are opened in a separate memory block known as PC register area. So all these program counter registers are opened in a separate memory block known as PC register area. All these program counter registers are opened in a separate memory block known as PC register area. It's a theory. Now, native methods, just read it as an one interview point only. Program counter register area means every method will be opened with one separate monitoring block known as a PC register. All these are opened in a separate memory block known as a PC register area. That's the concept. Native methods, one more small concept known as native methods. The methods which are declared with native keyword, the methods, if not the predefined methods, from Java library, which are declared with native keyword are known as native methods. One keyword you can see known as native. If any method declared with one keyword native, we are calling it as native methods. See in the library. So from the library, I am taking one class. The Java P nodes will be given. You have to wait it. Java.lang.object class. I'm opening one class known as object. So java.lang.object. So in this java.lang.object, some methods are declared with native, 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 and so on. The methods which are declared with native keyword, we are calling it as native methods. The methods which are declared with native keyword, we are calling it as native methods. Sir, why these methods are declared with native keyword? We must ask this question to the author. Author, why you kept one method with one keyword native? Native English meaning is local. Nativity certificate means local area certificate. So why you are calling them as local methods or native methods means your author said these methods internally having C or C++ codes. The methods internally we are written C or C++ code is available. So when the methods are having C or C++ code, then I represented with native keyword. So by seeing this native keyword as a code writer, I can understand this method internally having C or C++ codes. The statement I am recording here. These native methods, internally having C or C++ code. These native methods internally having C or C++ code. When the methods are having C or C++ code, you must copy into separate area. Come and copy into separate area because your code is C and C++. No, our area is Java area. Your method is having a C and C++ code, use it separately. So all these, nothing but when we use native methods when we use native methods, then they are separated and loaded onto separate memory block known as native method area. When we use native methods, then they are separated and loaded onto separate memory block known as native method area, because they are C and C++ codes now. So they are separated. Who separates means class loader subsystem. And your class loader subsystem will have decoders also. They'll decode and they'll identify and they'll make them native methods to available on the separate memory block here. So the native methods will come and load here. Finally, the native methods will come and load here. Native methods. Native methods are only predefined methods we had. Native methods are only predefined methods, means from the library only they will come. You must not write native methods. User defined native methods not there. As a code writer, as a developer, you never write native methods. So they will come from your library. They will come from your library. So you must not write native methods, because Java developer don't know C and C++ languages. So generally, in the real time also, developer will not write C and C++ code. Java developer means they'll write Java code only. If you know C language also, you must not write C code there. So that C codes will come in the form of library methods, and that methods are declared with one native keyword. When you use that method, automatically your class loader will load that into separate block known as a native method area. Then how they are executed, sir? Then how they are executed here? When the native methods are sitting here now, these native methods are executed with the support of JNI. These native methods are executed using JNI. JNI means Java native method interface. Java native method interface. This Java native method interface will support this execution engine. It's a part of execution engine only, normally. It's a part of it. So native methods are executed using JNI. This is libraries. When the execution is happening, this native method libraries will be used part of JNI. Means with the support of these two components, your native methods will be executed by your execution engine. Your execution engine means nothing but executor. This executor will execute with the support of JNI. The statement I'm making here. These native methods are executed using JNI, Java native method interface. These native methods are executed using JNI. And while execution, JNI uses native method library. While execution, JNI uses native method library. That's a concept. If any methods declared with native keyword, we are calling it as native methods. These native methods will come and load onto separate memory block known as native method area because they are C or C coded methods. When they are C and C coded method, you must load them separately because they must not mix with Java area. That's the information here. Now, so final summary like this. There are 5 blocks available, part of runtime data area, method area where class is loaded, heap area where object is created, Java stack area where methods are executed, nothing but execution area. PC register means monitoring the execution happens in Java stack. Native methods means loaded with native method area means loaded with native methods. Native methods also will come from library. Why they are specially loaded means because they are having C and C++ code. While execution engine want to execute this native method, it takes the support of JNI. It's a theory. All of you understood these 5 blocks and what they contain? Say yes or no to me for interview purpose. For one-time reading for the interview, 1 or 2 questions. So among that, always remember first 3 only. Method area, heap area, Java stack area. These 3 are important. Remaining 2, read once. When the interview is there, read once and go. First 3 you have to remember daily. Method area where our class loads. Heap area where our objects are created. Java stack area where methods are executed, like this. Now comes your last part known as execution engine. Here it comes as execution engine, the last part. Execution engine. Last part. Execution engine means executor. You can call it as processor, nothing wrong. Processor, English meaning is executor. Process means execute. So execution engine. Execution engine is an executor or processor of JVM. It is executor of JVM. Your machine executor processor, no? The same way. Java virtual machine executor is execution engine. Execution engine is an executor of JVM and which starts the execution process. Which starts the execution process with main method available in Java stack area. Very important point. So it want to start the execution means first the main method must be there. Sir, if I don't write main method, execution will not be started and the execution engine will not start the execution if main is not there. Because they'll ask one question, no? Can we write one Java program without main method? Not there. It cannot be executed. Main method is mandatory for execution because your execution engine is designed to start the execution from main method. That main method also standard format, public, static, void, main, standard format. If I don't write standard format, the main will not come. And execution engine will not start it. So execution engine is an executor of your virtual machine and which starts the execution process using execution process with the main method. So theory. All of you understood this statement? Say yes or no to me. Now, this execution engine internally having two translators. This execution engine internally having two translators. One is interpreter and one more is JIT compiler. JIT compiler. There are two translators available to us. Before concluding them, so two are available to it. One is interpreter, one is JIT compiler. Interpreter and JIT compiler. These two are available. Now anyone has to start the execution. Now all blocks came. Loader. So all blocks came now. Class loader, runtime data, and execution area. This is all blocks came generally. What happened? Roughly. Now, among this execution engine, two translators are available. One is interpreter and one is JIT compiler. Interpreter and JIT compiler. Now, who will start the execution process? Now, interpreter will start the execution process. Interpreter will start the execution process and executes normal instructions. Interpreter will start the execution process and executes normal instructions. In this process, if interpreter finds stream instructions means bulk data instructions. In this process, if interpreter finds stream instructions, then the control is transferred to the JIT compiler. Interpreter will start the execution process and executes normal instructions. In this process, if interpreter finds stream instructions, then the control is transferred to the JIT compiler. Sorry, your stream instruction means what, sir? Stream instructions means multimedia instructions like audio, video, image and animation. If you want to send any data like this, audio data, video data, image data, stream data, audio data, video data, image data, animate, they're all bulk data. So whenever you want to do this bulk data transfer, sir, why you are calling it as bulk? See there. Suppose I want to send one photograph, roughly. Suppose I had one photograph like this for understanding purpose. Some picture here. Cola.jpg. One picture, cola.jpg. The size of this is 762 KB. I want to transfer this image to database, or I want to put to my friend in the early morning, good morning, I must send one image. Daily will send one animations, images. When the festival comes, more multimedia data transfer will go. I want to put one image. Cola.jpg. For understanding purpose, I am writing. Cola.jpg, one image. The size of this image is 762 KB. So in the bytes also it is available, no? 780831 bytes. Seven 80831 bytes. Byte means how many bits, and byte means how many bits? You know already, 8-bit. So 8-bit. Byte means 8-bit. Here 780831 into 8. So these are the 62466648. 62466648, I think. 46648 bits. So I want to send these many bits, and I want to send these many bits. Whenever I want to send this image, I must send these many bits. 62 lakh bits, I think. I must send this much of data. So these all bits I must send it. Suppose I want to record this onto one database. Record this onto database. I must load this in the form of stream. That only stream data. Continuous flow of 62,466,48 bits will be traveling. That's the concept. To do this bulk data transfer, your execution engine will call JIT compiler because compiler will do all the work at a time. That only your Balaguru Swami said that. Total program compiled at a time. Interpreter will do the program line by line. Your Balaguru Swami will write it in the year 1, C language. Compiler will compile the total program at a time. Interpreter will compile the program line by line. So Balaguru Swami is student oriented terminology he uses, but actually all program at a time meaning is nothing but whenever I assign one component to you, compiler will do the total work at a time. Suppose I said 780831 bytes, transfer it, means compiler will transfer the total at a time. At a time means it will not live in the middle until that all bytes are completed. That only compiler. Interpreter will do line by line. It takes much time whenever it does line by line. So your execution engine is saying that normal instruction is there, I'll use interpreter. If any bulk transfers are there, any multimedias are there internally, automatically your algorithms are there internally, automatically your interpreter will transfer the control to JIT compiler. So JIT compiler will transfer that bulk data. It's a theory. So finally, JIT compiler, that only just in time means when the time arises, the compiler will come. When the time arises, the compiler will come. That's the meaning actually. When the time arises, compiler will come. If all are normal instructions, compiler will not come. The last about 2 programs what we written, why you written one program, I written one program. All are normal instructions only. Multimedia not there. So multimedia data will come, means will come. Files concept. Java program interacting with file storage. There we show that stream concept. Loading image, loading audio, loading video, we show it. So where we can use this concept means in advanced Java, in real time. Upload your photograph, upload your latest resume, upload your thumb impression. They are all multimedia data only, no? There the concept will help you. So internally what happened means JIT compiler will do the work. There is a knowledge. So JIT compiler will execute stream instructions from the program. Stream instructions from the program. Anybody knows DMA controller in your graduation study? DMA, full form of DMA. Anybody? Direct memory access. DMA means direct memory access. DMA controller, one word is there in your graduation study. The DMA controller design is nothing but, according to operating system, whenever it started transferring the data up to 200 KB to any memory, until it is transferred, nobody can disturb that transfer. That's called DMA control. DMA controller. The same behavior available for the JIT compiler. Once I given 700 KB, once it started, nobody can disturb that JIT compiler until that 700 KB is transferred. So JIT compiler will work like a DMA controller. So finally, remember like this: JVM executor or processor, we are calling it as execution engine. Execution engine having two translators. Execution engine is an executor of JVM and starts the execution from main method available from Java stack area. This execution engine or executor having two translators. One is interpreter, one is JIT compiler. So who starts the execution process? Your JIT compiler, interpreter will start the execution process and starts executing the normal instructions. Whenever it finds any bulk data transfer, nothing but multimedia data transfer by terminology, stream instructions, then automatically your interpreter will transfer the control to JIT compiler. JIT compiler will do the work. You speak in the interview. All of you got it now, this point. So that is your conclusion part like this. So whenever you started JVM architecture, I'll conclude it 5 minutes. Summary. Why we confer JVM architecture? Sir, our program byte code is loaded onto JVM for execution. Our byte code is loaded onto JVM for execution. So whenever our byte code is loading onto JVM, I must know the parts of JVM. So 3 parts: class loader subsystem, runtime data area, and execution engine. Very good question. I'll come there. One of your friend asked, sir, why interpreter is used? We can do with compiler. Very good. I'll come there. Now, 3 parts are there. Class loader subsystem. So class loader subsystem will load the required files into current running. Class loader subsystem will load the byte code onto JVM. It uses loader, linker, and initiate. Loader will load the required file. Linker will link the loaded files into current running program. Initiate component will create one memory known as runtime data area, having 5 blocks internally: method area, heap area, Java stack area, PC register area, native method area, and that method area is loaded with your class. That work is done by initiate. When the class is loaded onto method area, while class loading, main will get the memory automatically copied onto Java stack area. Once main copied onto Java stack area, it is detected by the execution engine and starts the execution process. Once execution process has been started, any new operator is available means object is created part of heap area. It is a general process happens in your language. Class loads onto method area, object creates in heap area, execution happens in Java stack area. That is a normal mode happening daily. What are the methods executing in Java stack area? Separate structures are opened in PC register area to monitor the methods. They are known as PC registers. All these PC registers are opened in a separate memory block known as PC register area. Because every method will have its own program counter register. It's a theory. Now, there are some methods part of Java library declared with native keyword known as native methods. When these native methods are used, then they are automatically copied onto separate memory block known as native method area. That's a theory. When this execution engine want to execute these native methods, then it takes the support of JNI, Java Native Method Interface. Now this execution engine starts the execution with main method with the support of interpreter. Whenever it finds stream instructions, then the control will come to JIT. This is the behavior. Sir, why we are using interpreter and compiler? One question will come. Generally, that question raises from the questions. Sorry, students generally. Because C language never use interpreter. C++ never use interpreter. Only Java will use interpreter. The reason, Java means client server architecture. Your Java came into market for internet world. Already C and C++ will do all the works. But even then in 95, your other brought this language into market by 95 as a client server architecture. Java means client server. So client server means server can provide service for multiple users. Server can provide service for multiple users. Now, the client is requesting, server is giving answer. Nothing but in that server Java program is doing some task. In the client server request, once the request has been given, execution started. In the middle of execution, again, the user has to pass one more request. In the middle of execution also, it has to accept the request. If compiler is there, it cannot accept. Compiler means it will not accept the request. Once it started, it will not leave it. Example, today I started online class. Offline class I started today. Yesterday I started offline class. So management given some students to me. I started one class roughly. Management said, sir, Venkatesh sir, you are a compiler. So take the students into room and start the syllabus. I am a compiler. So I went to one room and students are sitting there. I locked the door. There are some 37 chapters available in core Java. I started. I never come out of the room until the 37 chapters are ended. That's called compiler. Management is knocking the door from outside. I will not open because compiler cannot be disturbed in the middle. Compiler once started, it will not come out until it ends. That is very dangerous for client server architectures. Interpreter means like this. Interpreter, read carefully. Interpreter. In that interpreter, one word is there. Interrupt. Interpreter, interrupt. One word is there. Interrupt English meaning is disturbance. Now, management said, Venkatesh sir, you are interpreter. I went to that room and I knocked the door. Whenever I started chapter 1, somebody knocked the door. I'll open the door and see who is that. I'll speak to them. Again, I'll come inside. Again, I'll start it. Somebody knocked the door. Again, I'll go out. I'll see it. Come back. Means interpreter can be disturbed. Compiler cannot be disturbed. Because of this reason, other said, I'll keep interpreter so that if any user passes the request, interpreter will accept it. Because it is the executor, no? It can accept. If I keep the compiler, it will not accept it. It is not preferable for client server. To achieve the client server environment, your other brought an interpreter. Because of this reason, your language became interpreter language. I'll give the feature, advantages of your Java language, I'll give it. Understood this point? And your other brought interpreter to accept the request in the middle of execution. Interpreter available in the execution process to accept the request in the middle of execution. If interpreter not there, it will not accept. Client server support not there. That's the point. Okay, right. Again, we'll write that features of Java and 7 or 8 features, notes common in all the languages. So we'll write that. The notes will be given. I'll write in the 1 or 2 days, I'll write that. Features and object-oriented programming means what? Structured programming means what? That kind of questions, I'll write it. That's the point. Compiler will be very fast and when compared to interpreter. Generally speaking, compiler will be very fast because it will not live in the middle, no? It will not waste the time. Suppose I given 100 lines to the compiler. It finish off the underlines within 100 milliseconds. Suppose same underlines given to the interpreter, somebody disturbed in the middle. Somebody knocked the door, it gone, executed, came back. So 100 milliseconds may increase to 110 to 130. Interpreter will waste the time. Interpreter is not time performance. Because your other said, when the normal is there, you do. When the bulk is there, you will waste the time. 700 milliseconds, you will waste it. 700 KB given to interpreter, it will waste the time. If somebody knock the door, he'll go and work and come. To transfer that 700 KB, it takes much time. So don't do that interpreter. You give the control to JIT compiler because your other brought both the theory. All of you understood the overall behavior of JVM and just outline behavior of JVM, everyone. So why we write JVM means, why specifically JVM is written means, see there. JDK contains how many parts? Anybody can say? JDK contains majorly how many parts? And JDK stands for Java Developer Kit, which contains Java compiler, Java library, and JVM. Java compiler, anyway, we are not going to show any internal parts of Java compiler, we never show. Because compiler design available for one CS student already. We never show any compiler design here. But Java library, we are going to work it. Java library contains packages, we are going to work it anyway. JVM only once, so we completed JVM. And now we are going to work on Java library, opening the scanner class, opening the string class, opening the system class, opening like this. We are going to work on Java library. So remaining course will be running on Java library. So in the process of explaining JVM, if I want to explain one JVM, I need one program, no? Yes or no? If I want to explain one JVM, I need one program or not? Say yes or no to me. So because of this reason, I took the definition of one program and how to construct one program, how to execute one program. I took that model. To explain the JVM, I took the program. I took one example program and I completed my JVM. So theory. Now, after this JVM idea came with the knowledge, up to here, what is the summary you had? You know the program definition, you know the stages of program, you know the execution flow of a program. And you know where to write it, where to compile, where to save, where to execute, you know. And you know the class definition, you know the object definition, you know the class location, you know the object location. Say yes or no only. These are all points covered or not? From day one to today, what you learned? Program definition, program stages, program writing, program saving, program compiling, program execution, program flow, class definition, object definition, class location, object location. So these are the terms completed or not now. Without your knowledge, you completed these many components. So with this all theory, you are entering into remaining now. Remaining means naming conventions, one small chapter, data types. From now, the chapters will go now. From now, I'll write the topics what are to be covered. 1 minute. Right. So next coming topics are nothing but naming conventions in Java, data types in Java, operators in Java, control structures in Java, variables in Java, that's Java, blocks in Java, constructors in Java. Then introducing Java project using IDE Eclipse will be introduced. Here, packages. After packages, user-defined packages, then we introduced Java project using IDE. Then references, inheritance, interfaces, abstract classes, inner classes, exception handling, polymorphism, abstraction, encapsulation, typecasting in Java, wrapper classes in Java, strings in Java, object class, arrays, collection and map, then enum, then files, then multi-threading concept. So non-stop flow will go now, from now, topics. This is just outline and how they are coming in the order. Small, the minimum, these are all small components one. In the title I written, major outline titles I written here. So now the course comes to star mark IMP. Naming conventions. Naming conventions in Java. Naming conventions in Java. Naming conventions in Java. With naming conventions in Java. So that's naming conventions mean the rules which are used